In this video, we're going to be talking about solving equations with two operations. What I mean by that is that on the left-hand side here, you can see that we have two operations. Well, we've got a variable here, x, and we've gone ahead and we've taken x and we've multiplied it by 3. After we've multiplied x by 3, we've subtracted 2 from it. And when we do all that, we end up with 8. Okay, so there's two operations involved. It's the x times 3, and then there's the minus 2. Now, in order to solve these, we're going to undo each operation one at a time. The trick is to figure out which operation to do and when. Now, I've heard lots of students make the same mistake, and they say, okay, well, I know that with BEDMAS, I know that I'm supposed to do the multiplication before addition, so I'm going to get rid of that times 5 first, and then I'll do the 1, because multiplication comes before addition in BEDMAS. Well, the thing about algebra is that we're actually trying to work backwards. So we'll end up doing the exact opposite of BEDMAS, because we want to make sure that when we're undoing this equation, we're doing operations that affect the whole equation. And I'll show you what I mean in a minute. But the gist of it is that when you're solving an equation, you're going to work backwards to BEDMAS. So this is what it'll look like. The first operation that I'm going to undo is the plus 1. So I'm going to write this whole equation again, and I'm going to write 5x plus 1. I'm going to leave some space, equals 36. Okay? And the operation that I'm going to get rid of is the minus 1. And you'll see that when I do that, I can do it to both sides of the equation, and the plus 1 and the minus 1, they just cancel out. Okay, so I'm left with 5x equals, well, 36 minus 1 is 35, and now I can undo the times 5. So I do the same thing, I write 5x equals 35, and now I'm going to go divided by 5 divided by 5. When I do that, these will cancel, and I'm left with x equals, well, 35 divided by 5, that's equal to 7. All right. So I want to show you just one way that we can be sure that we're correct. So if we wanted to double check our answer, make sure that we did everything right, well, we can always verify. So what we can do is we can write 5 and say 5 times 7 plus 1. Is that equal to 36? Question mark. Well, 5 times 7 is 35, plus 1 is 36, and 36 is indeed equal to 36. So we give ourselves a little check mark. Awesome. We'll do one more quick example. 4x minus 1 equals 31. So I'm going to start by writing 4x minus 1 equals 31. You can see I've left some space for a plus 1. And when I do that, I will, I'll do that in a different color. These cancel, and I'm left with 4x equals 31 plus 1, or 4x equals 32. Now I'll get rid of that times 4. So I'll write 4x equals 32, and I'll write divided by 4 divided by 4. And I'm left with x equals 8. And finally, to check my answer, I just have to plug it in. So I'll go 4 times 8 minus 1. Is that equal to 31? Well, 4 times 8 is 32. And is 32 minus 1 equal to 31? Well, 32 minus 1 is 31. So 31 is equal to 31. We give ourselves a little check mark. Fantastic.